Now what we are going to do today, what we are going to do today is we have seen that Ohm's law yesterday, and today we'll be talking resistance in detail. Actually, whatever we are going to deal right now after this 10 minutes is nothing but it's not actually part of syllabus. But problem is that if you don't understand the concept of resistance, it becomes very difficult to digest the remaining topics, that is the series, parallel, and even power circuits. So main problem or main concept is that you should understand resistance, and only then it becomes easy. Now, yesterday we have seen through a concept that there is some kind of obstruction to the flow of electrons, right? So electrons want to travel in a very straight path from negative to positive. They want to go that way, but problem is that there is some obstruction which is created by atoms, and that obstruction we have given it a name. That obstruction name is resistance. So resistance is being offered by atoms to electrons, and every substance present on earth will have different kind of resistance, that we also seen. But yesterday we discussed that metals have low resistance and non-metals have high resistance. Today we are going to discuss that in detail, that why exactly metals have low resistance and why non-metals have high resistance. That we are going to discuss. So today's topic is very much simple. It is resistance in detail. So we have already studied this topic resistance, but we are going to add one more notch to it, some advanced version of resistance. Okay, so yesterday we had taken this example wherein what we did was we said that this particular atoms are present in the path, and this electron which is present at the end, left hand side, wants to go to the right hand side. That example we had taken, and it was being stopped in between by these atoms. So these atoms were acting as a distraction. Each atom was attracting this electron while going, but the force was so much of the electrode, positive electrode, that it broke through the attraction of these atoms and still went to that particular electrode. But problem created by this scenario was that it took certain extra time for this electron to move from one place to another, because it stopped in between, and this is nothing but called as obstruction. Today we are going to discuss some more details about it. Okay, so what we are going to understand today, that why metals have low resistance and why non-metals have high resistance. We just memorized it yesterday, but today what we are going to do is we are going to understand that why and how exactly is this happening. Okay, so first we have to understand what's the concept of free electron, and then we will discuss everything else. See, every atom consists of proton, electron, and neutron. That's a basic thing of any matter. You already know this from your lower grades, 8th and 9th, that every atom consists of proton, electron, neutron. So that means any material present around us has all these elements. TK means all these particles, proton, electron, and neutron. But problem is that in a particular material, not according to our information, electric current is nothing but flow of electrons, right? But as any substance will have different, suppose let's say, number of electrons, not every electron in a substance is taking part in electricity. So suppose let us say I have a material of iron, not all the electrons present in that iron material will take place in electricity. So they will not take part in electricity, all the electrons. Only few of the electrons present in that ion will take part in electric current flow. So we have to study that concept, free electrons. And free electrons are what? These are freely roaming electrons inside a material. So every material will have definite number of free electrons, and these free electrons are the only one who are responsible for our electric current. So main concept here is that not all electrons take part in electricity, only few of them take part, and those few of them who take part in electricity, in conduction of electricity, are called as free electrons. What is the meaning of free? Free means they are not connected to any atom. They are roaming freely inside that particular lattice structure. So they are responsible for carrying electric current. Do one thing, write down in your notebook that free electrons are nothing but electrons roaming freely, and they are responsible for carrying electric current. These 2 points I want you to write. It's very important. Only then we will understand that what is the difference between metals and non-metals. Once you are done, give me response in chat box that, sir, we have written this, we can proceed. Written? Okay, fine. So focus on this now. Situation inside particular metal and non-metal. So all these plus are nothing but atoms. Okay? All the plus which are present here are all atoms. And what we are trying to do here, we are trying to understand that what is the main difference between them. So all these plus values, the bigger circles, those are atoms. So metal has also atoms, non-metal has also atoms. Now focus on these shorter circles. These are electrons, but these are not any electrons. These are called as free electrons which are not inside the atom. So atom के अंदर नहीं है वो, they are outside the particular atom, hence they are called free electrons. Now you compare number of free electrons of a metal as compared to non-metal. You can see there are so many free electrons inside a metal, but in non-metal there are so few. ठीक है? Give me response in chat box. Have you understood the major difference between metal and non-metal? Metal has many free electrons, non-metal has less free electrons. Got this point? Okay, chalo. So next concept we'll try to understand. Now we are going to understand with again our same diagram, that previous one, that what happens with the metals. So what I have done is, this is a path I have taken, the upper part. This is a path and these are the free electrons. The red ones which you are seeing are the free electrons. They want to go from left side to right side. Okay? So right side we have connected to positive side of the battery and these electrons want to flow. So these are which electron? Free electrons. And here is one atom present for just our, what I can say, explanation. So I have not taken many atoms. I have just taken one atom so that we can understand what happens in this case. So देखो, they start moving. Electrons wants to go from left to right, right? So they are going. So once they reach, in this case, so many of these electrons will be attracted by sodium, as we have seen yesterday. So some of them will be attracted by sodium, but sodium cannot attract all these free electrons. It is not possible for it because there are so many electrons that sodium can attract only few of them. Not all of these electrons can be attracted by this atom. So what will happen? Only few of them will be attracted and the remaining ones will still continue with their path. They will still continue with their path. That means sodium was not able to stop all of them. Okay? Sodium was not able to stop all of them. Only few of them were stopped by sodium. Give me response in chat box. Have you understood that only few of them were stopped by sodium? Not all of them was possible. Okay, good. Now we will see what happens with non-metals. Okay? But before that, conclusion of this. See, not many of the electrons were stopped by sodium. Hence, all of them, almost all of them, went with their path. Okay? So not all of them were stopped, and hence they were able to complete their journey and they were able to flow. So as many of the electrons flowed through this particular circuit, we can say it was having low resistance. Because see, if number of electrons increase, so that means what? That electricity is more, and if electricity is more, so that means there was less resistance. You can see sodium was not able to attract all of them, so it has low resistance. It has low resistance. Sodium is a metal, so it was not able to attract all of them. So low resistance means what? Low resistance means what? High electric current. So high electric current was possible because of whom? Because of many electrons were able to complete their journey. Not many of them were getting attracted by sodium. So it's a very simple journey, that low resistance and high electric current. Tell me in your chat box, have you understood this example? That many of the free electrons were able to go from left to right and only few of them were, like, attracted by sodium. Okay, good. Now we will focus on non-metals. What happens with non-metals? Now, for example of non-metals, I have replaced sodium with sulfur. Okay, sulfur is a non-metal. Now focus on this. You can see the number of free electrons here. Now to begin with, non-metals have very less free electrons. That is the main difference. Now metals have many free electrons and non-metals have very few free electrons. तो बहुत ही कम है इसके पास. What? Free electrons. So they started their journey, as in the same case as metals, they also started their journey. So let us start their journey. They started their journey, and once they reached that sulfur tried to attract many of them. Okay? And it was able to attract. Okay? It was able to attract. Now problem is that not all of them was, let's say sulfur was not able to attract all of them. Only few of them he was able to attract. So rest of the electrons, they completed their journey. Okay, rest of the electrons, they completed their journey. But difference between this sulfur and sodium is that to begin with sulfur had very few electrons. पहले जो उसके पास एक तो पहले से भिखारी था, ठीक है, it was not rich with free electrons. It had very less free electrons, and when sulfur attracted a few of them, it left with only two or three. The case of sodium was very different because to begin with it had more free electrons, but non-metals very less free electrons, so only few of them, very few of them were able to complete their journey. Okay, give me a response in chat box. Have you understood the difference between the two scenarios? That in non-metals there are very less free electrons to begin with, and hence not many of them were able to complete their journey. Okay, correct. So main difference is that it has high resistance. Why this particular sulfur has high resistance, this non-metal has high resistance? Because to begin with it had no free electrons, और जितने भी थे वो सब who attracted them? Sulfur. To begin with कम थे, और उसमें से भी कम किसने कर लिए? सल्फर ने. So that is the main reason that non-metals, that is sulfur, is having high resistance. And high resistance means what? Low electric current. According to us, it is low electric current. Okay, now let us compare both of them. See, so main difference between metals and non-metals, just focus on the screen, do not write anything. Okay, so we have taken sodium here, we have taken sulfur here. To begin with, the main difference between both of them is metals have too many of free electrons. So even if sodium is able to attract few of them, okay, still the electrons were able to complete their journey. But in this case, to begin with, free electrons were less, and many of them were attracted by sulfur. So very few of them left. That is the main difference. So let us compare more. Now question is number of free electrons. So who had more number of free electrons? Metals or non-metals? Give me response. Who had more free electrons? Who had more free electrons? Metals or non-metals? Metals, correct? Okay. Now answer my second question. Does both provide resistance? ठीक है? Okay, so both provided obstruction. So sodium also provided obstruction, sulfur also provided obstruction, correct? Both were providing obstruction. That means sodium also provided resistance and sulfur also provided resistance. Okay, so what is the main difference between resistance of sodium and sulfur then? Both of them were able to provide resistance, but problem is sodium has so many free electrons that it is not possible for sodium to stop all of them. Hence, sodium, whenever we connected sodium with battery, it was able to conduct electricity. As many free electrons were able to complete the journey, so electricity passed through this sodium because it had too many free electrons. That is the main difference between the resistance of metal and non-metal. Okay? Give me response in chat box. Have you understood now that why metals have low resistance and why non-metals have high resistance? It's a simple concept of free electrons. It is just the concept of free electron, nothing more. Okay, ठीक है. Chalo. So we are trying to find out the relationship between today about the electric current and resistance. Yesterday through Ohm's law we have already reached this formula that V is equal to I into R. Veer. ठीक है? So we remembered it with the help of mnemonic Veer. Today we will continue more with that. So V is equal to IR. That is already the derivation of what? Ohm's law, that we know. Now I want you to remember one thing. See, whenever this kind of question is always asked in the exam, state Ohm's law. And I don't know, but students make a mistake here. They what they write is whenever this question comes, state Ohm's law, they simply write down the formula there, V is equal to IR. See, V is equal to IR is a derivation. It is not Ohm's law. It is a derivation. What is Ohm's law? Direct relationship between electric current and potential difference. So make no mistake, do not make that mistake in answering the simple question state Ohm's law. Do not write down V is equal to IR. What you have to write down? Direct relationship between potential difference and electric current. Give me response in chat box. Have you understood what to write in state Ohm law? Whenever this question is coming, state Ohm's law. What do you have to write? Relationship between, direct relation between electric current and potential difference. Okay. Chalo. So we will try to create a relationship between electric current and resistance today. So formula we have written V is equal to IR. Now suppose if I keep I as it is, and if I want to transfer R to the other side, R is in multiplication here. So once it reaches V, it will go into division. So it has become a new formula, I is equal to V by R. Now, this V is dependent on battery. I told you already. V is the unit for what? Potential difference. And this value will be very much constant for a battery. For example, you might be using a battery of 5 volt. You might be using a battery of 8 volts. That value is not going to change. Okay? So, do you agree with this statement that I can keep that V value as constant because battery value doesn't change? We are not changing battery. Give me response in chat box. Have you understood that V is supposed to be constant here? Correct. ठीक है. So if I want to replace this particular equal to sign with proportionality, generally what we do, we remove proportionality sign and then we introduce equal to. Now if I want to remove this equal to sign, I want to place that proportionality sign, I need to remove this constant value. So what I will do, I will put proportionality sign I, and this constant I will just remove it. I will place 1 there as constant is removed, and this R will remain as it is. I proportional to 1 by R. Now give me answer in chat box. What is the meaning of this? I is inversely proportional to R or directly proportional to R? Okay, Bassett, correct, inversely proportional. Yes, this is inversely proportional. Reason kya hai? Because resistance is in denominator position. It is not in numerator, it is in denominator. So that means I is inversely proportional to resistance. So there is inverse relation between what? Current and resistance. Current and resistance, what kind of relation they have? Inverse relation. Okay, so this is what I want you to write down, but focus on this first. Inverse relation means what? If I increases, R will decrease, and if I decrease, resistance will increase. That is the simple definition. So if we are talking about relationship. If current is doubled, just we are taking example. If current is doubled, then resistance will be halved. Halved means what? 1 by 2. So if current is doubled, it will become half resistance, and if resistance is doubled, then current will become half. Okay, it's just a simple explanation. Give me response in chat box. Have you understood the relationship between I and R? They are inversely proportional. That means if one increases, other will decrease. Okay, good. So that means if resistance increases, current will automatically decrease. Okay, fine. Now we have to take this particular simple example. Which of these materials will carry more current? Okay, that we are going to discuss. So there is material 1, there is material 2. One is having the value of 25 ohm and one is having the value of 100 ohm. Okay, so let me explain which of these materials will carry more current. We have been asked this question. So chalo, शुरुआत करते हैं. Material 125 ohm. What is the meaning of this? That 25 ohm is a low resistance as compared to 100 ohm. From both of this example, 25 value is less, right? So that means material 1 has low resistance and material 2 will have high resistance. That means if material 1 has low resistance, it simply means that it can carry more current. Low resistance means high current and high resistance means what? Low current. That means if a value of a material is given in terms of resistance, we can easily say which of the materials will carry more current. Give me response in chat box. Have you understood how we can judge a material can give more current or not depending on their resistance? Okay, good. Fine, fine, fine. Chalo. So next question. Now practical application we have to see. Can we really decrease electric current? Is there any practical application for this? Can we decrease electric current, and are there some, let's say, some examples in our life which we use? So we'll see this example. This is your regular fan knob. Okay, fan knob. This is also, you also know it by another name, that is its regulator. So these days we have a very small size regulator at our homes for fans. So this regulator which we have taken into example, this has only 4 options. Either you can turn it off, or it has 1, 2 and 3 speed. So speed 1, speed 2, speed 3. Now I want your responses very fast. Okay? Do you agree that at 1 there will be low speed, at 2 medium, and at 3 high speed of the fan? Give me response so that we can move one by one. Okay, good. Second stage. Okay. Do you agree that if suppose let's say the fan is working at a low speed, that means it is not moving very fast. So that means it must be getting very less electric current. Fan is getting very less electric current at 1 and hence speed is low. Agreed? Okay. So that means at 3 it will be having high speed and it will have high electric current. ठीक है? Now, according to our information, if there is less supply of electricity at 1, what might be greater? Resistance will be greater or lower, higher or lower at 1? What do you think? If electric current is less, what would be the resistance at 1? Very high, correct? एक पे ज्यादा होगा. Resistance would be more at 1. Reason, what is the reason? Because electricity is less at 1. Correct. So we have come to the simple conclusion that at 1 there is very low speed because less electric current was flowing, and less electric current is possible only if there is high resistance. Less current is possible only if there is high resistance. So at 3 we'll compare. See, we won't be discussing 2 because everything is medium. Let us talk about 3. So at 3 the speed of the fan could be very high. That means it is getting supplied with high electric current, and in simple terms it means it has low resistance because high electric current is flowing, right? That means high value of I, automatically it means low resistance. Correct? Okay. Now let us move to the next one. Now question is that what happens when we change the speed of the fan from the knob? What exactly are we changing? What exactly are we changing by rotating this particular knob? Okay, so answer is very simple for this. What is the answer? Give me response in chat box. What are we changing by moving this knob? We are actually changing resistance. We are changing resistance. We are changing the resistance value. As soon as we change the resistance, it will have different electric current and the speeds will change. We are not changing speeds. Okay, we are changing resistance because of which electric current is changing, because of which speed is changing. Okay, good. Check. Now next question, what is the use of this device? Okay, the main use of this device is to change resistance, that we know. Okay, it is used to change the resistance of fan. Okay, now question is, we are going to see one thing, something called as fixed and variable resistance. What is the main difference between the two? So I have taken, for example, here I have taken iron wire. Okay, just focus on this. So it's a bundle of iron. Okay, so I have beaten that iron into wires and I have a big bundle of iron. Now problem is that it is something called as fixed resistance. It is called as fixed resistance. You have already seen in the example of fan knob that you were able to change the resistance by moving that particular knob to 1, then 2 and 3. You were changing resistance. But in this case, in this iron wire, you cannot change the resistance. It has fixed resistance. There is no knob or switch in which you can turn and you can change the resistance. So resistance change is possible only with what? Fan knobs. But materials won't have different resistance. They will have fixed resistance. Are you getting my point? What is the main difference between fixed resistance and variable resistance? Variable resistance means what? If resistance will change, and fixed resistance means what? Resistance of those materials will never change. Okay. Give me response in chat box. Have you understood that different resistance means what? It's a variable resistance. And fixed resistance means what? Resistance won't change. Okay, fine. Now we are going to see some materials which are available in the market, which are having some fixed resistance and some are having variable resistance. So these small tiny devices, these are even shorter than your finger. Okay? These devices which you are seeing in front of you, these are electronic devices and these are called as resistors. Okay? Not resistance. Huh? This device name is called as resistor. Resistor, and it's a fixed resistance. So that means if you go to the market, these are the possible solutions. Now, for example, you might be going to a market, you can buy, suppose if you want to buy a dairy milk, for example. So you can buy dairy milk of 5 rupees also, 10 rupees also. You can also buy a dairy milk of 100 rupees also. Okay? Give me response in chat box. At least do you agree that there are different types of dairy milks available in the market? ठीक है, at different rates you can buy. Okay, in the same case resistors are having different resistance. ठीक है, they are made from a particular material. These are manufactured by the companies and they are having fixed resistance. For example, I will take the first one. So suppose let's say it has 25 ohm resistance. If you went to a shop, you asked him to show resistor, he showed you this resistor, the first one, and he told you that resistance of this device is 25 ohm. So you cannot change the resistance of this device. It will remain 25 whatever you do. For example, he showed you the last one. He said the resistance of this device is 10 ohm. So according to your application, you can buy, but you cannot change the resistance of these devices. These are called as resistors, generally used in science labs. So science labs mein it is used. Give me response in chat box. Have you understood that resistors are available in plenty in market and we can have different resistance of these things? Okay, good. Chalo. These are called as fixed resistance. Now focus on the next part. There is one more material which is available in market. So for science labs or for science applications, whenever we are testing something, so we cannot use fan knobs each time. So instead of fan knobs, we have different instrument which is available in the market. We have actually seen this, okay, but we have not discussed about it. So last time in the symbols we have seen this. This device is called as rheostat. Rheostat. It is called as rheostat. What is the meaning of rheostat? That this device is having variable resistance. Resistance. So if you go to the market, you ask them that I want to buy rheostat. He will say that we have a range. So that means if he says that we have a rheostat who has a range of 0 to 25 ohm, so that means by using this rheostat, the minimum value possible is 0 ohm and maximum value possible is 25 ohm. And if he says that we have also another rheostat having the range of 0 to 200, so that means it's a bigger kind of rheostat. My minimum value is 0, maximum value is 200. Okay. Okay. Now I will just give you example that how exactly this rheostat works and what kind of things are possible with this. So first thing we will see how to use this. Okay, it's a small device. How to connect this in our circuit. So you can see the knobs here. You just have to connect one wire to one of the terminals and another wire to another terminal. Okay. So these are the two terminals to which wires are supposed to be joined. Now focus on this, the upper knob. It actually moves from left to right. You can move it. It moves. And what is the use of this? For example, if you have bought a rheostat of the range of 0 ohm to 25 ohm, so on one side, if you take it, if I take this knob, this particular knob to left hand side, the value I will get is 0 ohm. The markings are not made on this rheostat. Hence, it's actually difficult to use. Like for example, on the knob and knob values were given, right? So one value is given, two is given, three is given. But on rheostat, these readings are not available. So you have to take it randomly. So if you just go to one end, you will get the minimum value. And if you take it to another end, you will get the maximum value possible. Okay? Give me response in chat box. Have you understood what is the difference between resistor and rheostat? Resistor was having a fixed resistance, but in rheostat you can change it. All you need to do is move that upper knob. Okay. Awudi, it can be made from different materials. Different materials are used, generally nichrome, magnesium, different alloys are used. So it's a manufactured device. Different materials can be used. Basaid, what is the use of resistor? Okay, that is used for testing purpose. Also, it is used for example, to give some specific value. Generally, it is used in radios, sometimes in computer as well. All the electronic devices uses this particular thing called as resistor. Currently, we are not going into detail, but you can just remember that these things are having fixed resistance and variable resistance. About we will be discussing about temperature later, not right now. Chalo. Now question is, what is variable resistance? So variable resistance is what? A component used to regulate electric current. In the exam, they will ask you the definition of variable resistance. And what is the meaning of it? A component used to regulate current without changing the voltage source. We didn't change the voltage source. What we changed was electric current. So regulating current is possible, and that is possible with the help of resistance change. So such devices are called as variable resistance. and we already know one of the examples of variable resistance is rheostat. Okay, one of the example is rheostat and another example is potentiometer. Okay, we will see potentiometer now, but you must at least know till now that rheostat is a variable resistance. We can change the resistance of this device by moving the knob which is present on top of it. Give me response in chat box. Have you understood what is the main use of rheostat? It can be used to change resistance, just like our fan knob. It is simply something like our fan knob, but a different version of it used in science labs. Okay, good. Now we will see what is potentiometer. So this is potentiometer. Now potentiometers are generally used in toys. I don't know whether you have really observed it or not, but these devices are generally present in toys, small toys. The toys which have, suppose, let's say, motors, generally those remote control cars and all small toys, they generally have these kind of small devices. This is called as potentiometer. And how to use this? So as we had that knob which was present on rheostat, we changed resistance. In the same way, potentiometer resistance can be changed by this knob. All you need to do is rotate it in one of the directions. You can rotate and you can increase the resistance. If you move it in reverse direction, resistance will decrease. It's a simple one. It is mentioned on top of it. So all you need to do is move the top part of it and the resistance will change for this device. So potentiometer is example of variable resistance. Give me response in chat box. Have you understood that potentiometer is a example of variable resistance? It is generally used in toys. Okay? Also in some major devices. Okay, and it is also used in some of the radios also. Old radios, they used to have examples of these potentiometers. Whenever you are turning knobs, it is generally potentiometer. Range of the potentiometers is different. It depends on the manufacturer. It can be manufactured in different cases. Something like our dairy milk, they can manufacture for 5 rupees also. They can manufacture dairy milks of 500, 200 rupees also. So range of potentiometer doesn't matter because it depends on what? Customer and the company. Okay. So we will learn this simple thing now. Just revise the symbols and then we will close our session. Now focus on this. Last time I said that please just memorize the symbols and we will discuss about the symbols later someday when we will complete the concept of resistance. So now is the time to discuss about the symbols of resistance. So resistance is generally denoted by these zigzag lines, But the meaning of this zigzag line is that it is the symbol of fixed resistance. This first symbol, this is a symbol for what? Fixed resistance. And these other two are the symbols of variable resistance. So we will see one by one. So the component you saw, that is resistor, the symbol of resistor is this one, zigzag lines. So these zigzag lines are what? Resistor. This is the symbol of it because the resistance cannot change of this device. Now of these things, this is your fan knob, regular fan knob, and this is the example what? Potentiometer, you already seen. These are variable resistance, and for that what they do, they just keep those zigzag line as it is, but they keep an arrow over it. The meaning of this arrow is that this resistance can be changed. Okay? Give me response in chat box. Have you understood the main difference between symbol of fixed resistance, this one, and this one, variable resistance? समझ में आया? Okay, and arrow over that zigzag lines means that resistance can be changed. Okay, now focus on this. This device is nothing but rheostat, that we know. But you have to understand that rheostat has a special symbol of it. खुद का symbol है उसका. Means actually rheostat can also be denoted by this symbol. But rheostat has a special, what I can say, symbol of it. खुद का symbol है उसका. And that symbol is very simple. Just draw zigzag lines, and instead of drawing that arrow over it, you show from the top. You show that arrow from the top, and this is the symbol of rheostat. Give me response in chat box. Have you understood the basic difference between variable resistance symbol and rheostat symbol? Rheostat has its own special symbol. खुद का symbol है उसके पास. Okay, good. Now what we are going to do now is, tomorrow we'll be studying about this particular activity, that is activity 12.2.